Good afternoon, everyone.
Good afternoon.
Good afternoon, everyone. Is Mr. Shand in, is it?
No, he's not in here as it.
Thank you, Tennille.
Good afternoon, students. Thanks for Danny here in class tonight. Oh my goodness, thank you. So as you would have been informed, Mrs. Henningham is going to be doing the tutorial session, which is starting now for an hour. I am actually in transit getting from Excelsior, but the good thing about it is that I'm almost home this time. So I'm just going to wait about another 5 minutes for the rest to join. And hopefully within 5 minutes, I should be closer to home. And then Mrs. Henningham, you can just go ahead. So we'll start at about, oh, it's just 5:30 now. Okay, all right. So we'll wait until 5:35 so we can start. All right, so the rest of you, if you could send out a message to the other students in the WhatsApp group to tell them to come out now, please, I would appreciate it as I am driving. All right, thank you.
Okay, sir, thank you.
Yeah, man, no problem. Oh my goodness. Why people just don't stay at work later so that I can get home early? Or leave work earlier. Oh man.
Mr. Shand, you're
Oh,
not muted.
oh, thank you, dearest. Um, I'm, oh, Lord. I just woke up into one and the traffic feel nice and say, yes, I'm home. All right, where am I? All right. We have 11 of them here, Mrs. Henningham. I am seeing the three. Okay. All right. Miss, you can begin. Go ahead, Miss. You can start.
Okay, thank you, Mr. Shand. Good afternoon, everyone. I am Natisha Henningham.
Good
And
afternoon, Miss.
thank you. That is Tati. Thank you,
Yes, Miss.
everyone. Yes, and thank you for your support as well. All right, so this afternoon, I'll be sharing with you for 1 hour during your tutorial. And let's see how it goes, right? So I'll start off by sharing my screen. And since as this is the first time, I'm actually starting off with you guys. Tati, can you say a sentence prayer for me, please?
Repeat, miss.
1 sentence prayer. Let us start off, please.
Prayer.
Yes, 1 sentence, 1 sentence.
Okay. Most righteous and heavenly Father, thank you for bringing us together. May this class be very informative and we all walk away learning something new. Amen.
Amen. 1 sentence is good. All right. Thank you, Tati. So, if I may say, Tati, call you Tati. So let's me start sharing my screen as we get the ball rolling. All right. Are you seeing my screen, everyone?
Yes,
Yes,
miss.
miss.
Taking you
Yes,
back
miss.
in the old days. Very simple. So what I'll be doing, just to smooth things off as we start, we're going to start very, very slow, and then we're going to be picking up. Who remember this? Fill in the blank. You remember that activity from before even high school? No?
Yes.
Yes, miss.
Right. So the topic for today, before we go into fill in the blank, we'll be focusing on matrices and systems of equations. We'll be focusing on doing determinants, how to find the determinants for the matrices, okay? Especially a 3x3, which I see recurring into the CAPE syllabus, right? So that is a popular question whenever matrices come up. So at the end of this session, you'll be representing data in the matrix form, A times X equal B, that is it, right? And we'll be evaluating the determinant of a 3x3 matrix, solve a system of 3 linear equations with 3 unknowns using the Cramer's rule. Have you been introduced to another rule?
No, miss. Only
No,
Kramer.
miss.
Really? Okay, so we need to expose and share on the other rule, right? But CAPE normally asks for the Cramer's rule, so it's a good one to focus on. So quickly, let us go through. We don't have much time. So just it's given me a few minutes until he's settled in, right? So the fill in the blank we're doing now. V, if you can assist me, you can read ahead and fill in the blank for me. So the terms at the top, ith row, number, a 2x2 matrix, square matrix, jth column, a 2x2 matrix, again, and determinant. So we're going to just quickly populate it just to get our minds back into the matrix form. And then we're going to hit the road with some questions. How about that?
Yes,
No
miss.
problem.
Sounds good.
Nice. Thank you for your support. All right, so let's get it going. So what do you think goes here?
Determinant.
Nice. The determinant of a matrix is what do you think the determinant is?
Number.
It's the number, right? And let me put in an additional term, which tell me if this would fit in as well.
Yes, miss. Yes, miss.
Yes, miss.
You're sure? So
Yes,
the
miss.
determinant of a matrix is the scalar value or number. That's what you're saying?
Yes, miss.
Okay.
Yes, miss.
Calculated using a,
2 by 2 matrix.
can it be used, can you use the determinant to calculate using, say, a 2 by 1?
No.
No, miss.
No, miss.
Okay. By the end of the session, you'll be telling me yes or no confidently and why not, right? So the square matrix could be, here they are, 2 by 2, 3 by 3, 4 by 4, or any other type. You tell me a type which would be impossible for us to do manually here. A 5 by 5 or I of 5. You can have 7 by 7, anything that is square, right? As long as the what? The row.
And the column is equal.
And the column are equal.
Nice, nice. So in calculating the determinant, what is the principle here? So we have the determinant of A. How do you find the determinant of matrix A?
It's the leading diagonal by the second diagonal.
What about the leading diagonal? What do you do to the leading
So,
diagonal?
you multiply the leading you multiply the leading diagonal by each other, and then you minus from the other diagonal.
Thank you very much. So you minus from the product of the non-leading diagonal, right?
Yes.
Right. So the minor of, and thank you very much. Who was that speaking? Can you, when you're sharing, can you just say your name for me, please?
Okay, it was Taniel.
Taniel, thank you very much. So we are moving on. The minor of an element, a to the ij, of a square matrix of any order is the determinant of the matrix that is obtained by removing the what? Have you ever met upon this term, the minor of an element? I'm sure you have, but as we go through, you will see exactly what I'm talking about, okay? So it is when you remove the ith row or the jth column in question. Does that sound familiar when you're doing the Kramer's rule?
Yes, miss.
Yes, miss.
Tell me what exactly am I talking about now? For example, anybody? No example? Okay, let's move on. Let me see what example I have here, right? So here we have a matrix A. And how many elements are in matrix A?
9.
9 elements. So if I say, A, 2, A2, 2. What element is that?
5.
5. Right. So you know how to locate your elements. That is nice. So here we have the minor element of 6 being noted. Do you recognize that wherever the row or the column that element is, what happens to it? What is happening to it right here?
It's being marked off.
It is being marked off. Is it Stanil again? Tanil?
Yes, miss.
Right. Thank you very much, Tanil. The others, you may feel free to participate, okay? So this is just taking you way back, way back. You've done past this long time already, right? So this is baby stuff for you. So here we have the column and the row being marked off because we are trying to find the determinant here, right? And what would it be? So we'll leave 1, 2, the elements 1, 2, 7, and 8. And how do you find the determinant here? It is noted right here now. First, the leading diagonal as we describe it, is take the 1 times it by the 8, and if the difference between that and 2 and 7. So it's 8 minus the 14, giving you -6, right?
Yes,
All right.
ma'am.
Let's
Yes,
move on
miss.
to some practice questions. So gone are those baby stuff. So before we move on to the worksheet, this is not new to you guys, right?
No,
No,
miss.
miss.
So I need to see who it is that is saying no. How do I see my participants? Come, say no again.
No,
Are we?
No, miss.
No, miss.
Dante, Danik. Oh, so it's many of you. So practically all of the class is not new to. Very nice. So I'm not gonna have any issue in you. Just let us start out with something simple. Probably you would have seen this question in your specimen paper. Tell me that you have tried it. No?
I think so.
All right. Nice. And I'm picking up on the voice. Who is the voice again? Danik or
Daniel.
Tanil? So Tanil, you are the one who has done this question already. What about the other class? How many minutes do you think you can do this in? This is 7 marks. Ensure to take out the mark to include the marks as well. So we're going to attempt this question, everybody, and we're all going to apply what we have just discussed in finding the determinant. The question did not say find the determinant in section 1. First, it asks you to express the following system of equations in the matrix form AX equal B. And then for the part 2 of the question, it asks you to use the Kramer's rule and show that the determinant of A is equal to 24 and to solve the system of equations. Baby stuff, right? Daniel, where's Daniel? Anybody else is not baby stuff? Listen, Mr. Shan here.
Well, when we work it out, we'll see.
Thank you, Daniel. Mr. Shan, depending on you guys, he is confident that he has taught and conveyed.
Miss,
What?
but when you learn, when you learn it, fine. But then when you get the question to do, the whole different scenario.
Okay, this is Kimo. Pronounce her name for me, please. Kimoli?
It's Kimali.
Kimoli. Miss Heslop. That is fine, right? Nice. Miss Heslop. We're finding the name and the pronunciation fit suiting. Miss Heslop, don't worry yourself about it. That is why we are here. And if we work, it's not only one grade 1 out there, you know. 20 participants, including myself. Suppose I get one in there too. You may never know, it's not one out there. So I'm asking you to attempt this question. If you want me to go back up to the introduction part of it, no problem. Take down this question, we will be working it out. And I'm encouraging you to make use of this time. It is a time for you to come out, and if you don't understand, you talk. You see how quick Mr. Shan going? Because who has an exam? Which one of you have exam in May, early May? Nobody. All of us. Right. So now is the time for you to vocalize. If you have any question, you say, okay, I know sir did it, but I did not get this part of it. And we are going to work as a team to ensure that the understanding is correct and everybody can get a 1. What's the highest mark in Cape? Or everybody want a 5? A 5 everybody working for? I don't understand.
No, miss.
Exactly. It's what is it's a 5 you're working for. No, everybody going to get a 1. All right. So take down this question and I'm going to give you, let's go for 6 minutes to see how far you reach. Okay.
Okay, miss.
Yes.
Yes, miss.
Nice. So not to rush you, but has anyone come up with what AX equal B is?
Yes.
Yes, miss.
Okay, let's use a strategy in this session. So if Danik answer, we're doing one question, Danik answer one time, we have to be certain that there is nobody else in the class who can answer before Danik answer again. Can we try? But the person speaking can always, ask for Danik to assist. Can we try that one?
Yes, miss.
All right, so who is going to give me AX equal B?
Me, miss.
Go ahead. You want me to start out for you?
Miss, they're going to have 1, 1, 1. That's the first row.
Okay, Shante, go ahead.
Then 2, -3, 0. Then 4, 1, -2. Then you have x, y, z equals 4, 7, 1.
Can somebody else confirm that Shante is doing the correct thing?
Yes, that's right.
Yes, miss.
Okay, Tanil. So who else has gone to show that the determinant of A is equal to 24? Do you remember what to do?
Yes, miss.
Yes, miss.
Yes, miss.
All right, 3 so far. I'm not taking away from the 5 minutes, so take your 5 minutes. I'll keep quiet on this one. How are we getting along?
Getting there.
Yes, sir.
Okay, nice. Wait, so 5 minutes long time has gone. Ready for me?
Not yet, miss.
Not yet.
Miss, all you have to do is prove that A equals 24.
No, it says to prove that A is equal to 24. The determinant of A, that's what we're proving. So, and then we are going to solve the system of equations. Looking over some past papers, what I found, what I recognize is that it says, given that A is equal to, right? I recognize that they actually applied a mark to it. So can you imagine if we did not prove it? We'll be losing a mark right there. And it's them who gave us the assumption, you know. It says, given that the determinant of A is equal to 24, and then solve. Some persons would just go ahead and solve. But reviewing this question and looking at the answer, that's why I went to the specimen paper. A mark was allocated for it. So keep that in mind when you're doing your exam. Well, sir will advise you more. Have to refer to the more experienced. But what I saw is that they gave a mark for it. So is anyone ready?
Not yet.
Okay. Just 2 more minutes and that's it. 2 more minutes. Okay, we're going to attempt it. We are going to attempt this question. But first, I need to know what you understand from this question before we look at the solution. Fair?
Yes, miss.
All right, Shantae. All right. Let's start out with Kesana. Are you able to speak?
Yes, miss.
All right. Were you able to put the question in the form AX equal B? Nice. Has everyone been able to do that? You want me to
Yes,
go on?
Yes.
Yes, miss.
Okay. Let me see if I can. So everybody is on the same page with that part of the question. So the next part is to prove or to show that the determinant of A is equal to 24. Can somebody remind me, how do you find the determinant of a matrix? We're just talking here.
First, you would apply the array of signs,
Mhm.
and then you would pick a row.
When you say the array of signs, what do you mean?
So for the first element will be plus, then you go on minus, plus, minus, plus, minus, plus.
Tatiana, sound like you're playing checkers, man. But is that correct? Can somebody else say if it is correct what Tatiana is saying?
Yes, miss. Yes, miss. With a positive sign and in with a positive sign.
Okay, nice. So everybody is with Tatiana on that?
Yes, ma'am.
Yes, miss.
Nice. All right. So go ahead now, Tatiana. We put it, is it to each element? Or is it to the row or the column? What is it?
Oh yes, miss, the row or column that you'll be using.
The row or column? Which one is it?
Each element.
To each element?
So
Yes, by the rules,
element-
it will work out to each element. But let's visualize it. So you would put, say, the plus here, right? You
Yes,
see
miss.
where the mouse is? The minus here, and it will go for all the elements in it, right? Okay, then continue, Tatiana. I understand what you're saying. Continue.
And then you would pick a row or column, preferably with the most zeros.
Mm-hmm.
And then you would choose the first number in that row or column. You'd apply the sign to that number, and then you would find the 2 by 2 matrix that would come out of that. So then you would, just like how you're marking those off, row or column that number is in, the row and column that the number is in, you can mark off the other numbers. Like cross out that column or and the row, and then you'd see the numbers that would be in the 2 by 2 matrix.
Okay.
And you
Kesana, are you following?
Yes, miss.
Does that make sense to you?
Yes, miss.
All right, Tatiana, you're doing a good job, man. Continue. Excited about it. Continue.
Then when you get to the second line, you would have the cofactor. That's the one that the number you apply the array of sign to. Then you go to the 2 by 2 matrix, and then you multiply the values of the leading diagonal. Then you would subtract from that the product of the other diagonal.
The non-leading.
Yes, the non-leading diagonal. And then you just continue to do that for all the other elements that you got, basically.
So you do it for all 9 elements here?
No, miss, for all
You
the
do it
other
for
in the
what?
row or column.
Oh, okay. All right. Okay. And then, so tell me now, how far did you reach, Tatiana?
Yes, I
What is
finished.
the answer for? You finished? So tell me the answers that you got.
Yes, I didn't put them in fraction, you know. So
You didn't put them in fraction?
no, I was going to do that. So technically I'm not finished.
Okay. All right. So thank you very much, Tatiana. You have explained yourself. Is there anything different that you'd like to add the other students? Is your understanding different? It may not be wrong, you know. It's just how you understand it. All right, let's take it down to the solution. So I'm going to skip over my other questions and go down to the solution. And let's see if we can follow Tatiana's explanation. How about that, Kesana? We have just about 13 minutes and we need to do the other question as well. All right. So everybody following?
Yes, miss.
Is this in the form AX equal B?
Yes.
Yes, miss.
Yes, miss.
All right. Let me pick on somebody today. Is it possible for me to hear from? Just a simple question. Miss Campbell. Miss Campbell? Is it Javia?
Yes.
Right, Javia, tell me what is it that represents the X in this form?
Miss. Variables.
The variables, the X, Y, and Z,
Yes.
and B would be the 4, 7, and 1. That is too simple. All right, Javia, continuing with you. So we're going to prove that the determinant of A is equal to 24. Right? So with the element of the focus here is on which one now? The one, right? This one. So we're taking this one, the first element in the matrix, and we're putting it right here outside. So if the focus is this one, let's not get it complicated. What is the 2 by 2 matrix that is formed? You're seeing it?
Yes, miss.
So we're talking about the minor matrix here. So the -3, so we cross out these. That's all Tatiana was saying, put in the zeros. That's what you were saying, Tati?
I was going to choose the row or column with the most zeros.
Okay, so you want to start working from row 2 or column 3.
Yes, miss.
So how would you do that? Javia, you're not off as yet. Javia and Tatiana walking us through the question. So let me hear what you do here, Tatiana.
Miss, I use the second row. So I have -2 based on the array of signs. And then the 2 by 2 matrix that would come out of that is in the first row, you have 1, then 1, second row, 1, and then -2. And then
so you're using -2 here.
yes, miss.
And you said that the matrix you're forming, you have formed is 1, 1, 1, and 2, or is it 2 and
-2.
-3? All right. Let's see. So I use a tool which is different from what I have here. And what is the answer that what is the answer you got for that one?
24.
You got the 24. Okay, I need to try it. I'm going to write it down to try it. Try it your way. All right. But Javia,
Yes, ma'am.
back to you.
Okay.
So thank you, Tatiana. I'm going to try your method, right? Because there's always more than one way, but the principle sounds similar. So I'm going to research it and come back to you. So for this here, what I did was I put the one outside because I'm focusing on this one here. I'm going across the row, the first row I'm using, right? And then the matrix, the 2 by 2 matrix which result is a -3, the 0, the 1, and the -2, right? So each element I'm focusing on. So I'm going to the second now. Tatiana spoke of the checker approach. So we'd have the plus, right, which is here, the minus, which is here, and the plus for the third column, which is here, right? And so when you have those signs now, all I did, I placed the elements in the row of focus. So when I reach the second column, see, I would eliminate the second column and what else? The first row. And I'm left with 2, 4, 0, and -2. Right? You're seeing that, everybody?
Yes, yes.
Yes.
And for the third column now, the third element in the row, the third column, I'm putting the 1, right? And then what would be the 2 by 2 matrix with that result? The 2, the 4, the -3, and the 2.
And 1.
And the 1. Thank you very much. So when we work it out, Tatiana said that she got the 24, right?
Yes, ma'am.
And this is how you prove when you work it out. So you say 3 times -3 times -2, give it a +6. 1 times 0, you get back a 0. So let's go and work out put the elements in the bracket first. So we have the -1. So we have 2 times -2, give it a -4. 4 times 0, 0. We continue, plus 2 times 1, 2, 4 threes, 4 times -3, -12. But what are we doing here? We're minusing the product of the non-leading variable, non-leading diagonal, right? So that's how you end up with a positive sign here. And then we continue.
Just can you repeat that?
We are minusing, we're subtracting the product. 4 times -3 gives a -12, a -12. So it will be written like this. Minus, and you have a negative. So you get the positive?
Yes, miss.
Right. So it's 2 plus the 12, give it the 14. The 2 plus the 12 times the 1 outside, give it the 14. We have the 4, the -4, minus the 0, -4, times the -1, give it a positive, the 2 signs. A minus times a minus, give it a positive. And then the 6 minus is the 0, which is a 6. And time is coming down, so we need to go quicker to just complete this, right? So everybody seen how we get the 24? Are we all on the same page?
Yes, miss.
Yes, miss.
All right, so let's go down now. So we're solving for X, Y, and Z, and we don't want to take up much of a lesson more, much more of a lesson, so we're going to go a little faster. So to find what the value of X is, it is the determinant of AX, so the A with the subscript X over the determinant of A, and we just found the determinant of A up here to be what? Quick.
24.
24. Nice. So we're going to use the same approach here. The determinant of AX, we're finding it the same. So, but this principle, this Cramer's rule, what is required here is that we are equating AX is equal to B. So wherever the first, since we're solving for X, right? So the assumption is here that the element in the first
Column.
column, does that represent which of the variable?
X.
X. Is everybody with me on that?
Yes,
Yes, miss.
yes, miss.
Yes.
The column, the second column represents which variable?
Y.
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 And in the third?
Z.
C.
Right, so everybody is with me now. Right, so because we want to find the X, the first column, we are going to replace the first column equated to the answer in the equation here. Sorry guys, something just went with the audio on my computer. I'm just picking up from where I left off. Let me mute so that you don't have feedback, right? So let's continue with the question. You're still seeing my monitor?
Yes,
Yes.
miss.
Yes,
All right,
miss.
nice. So we're going to go quickly because we're into Mr. Shan's time and we need to ensure that you get it, okay? So we have proven that the determinant of A is 24, and now we're working out what X is, right? So now we have replaced the X column with what the answer is, right? So it's 471 is the answer to what the equation had worked out to be, right? Yes,
Yes,
no,
miss.
maybe.
Miss.
Right. So now we're going to find the minor matrix from that one. Somebody tell me what the minor matrix will work out to be.
48.
Ah, who said that? Come on, bright spark. Who said that? Nice. Right? So we're doing the same thing. Thank you very much for that response. So the 4, same thing, take out the minor matrix here, and the -3, 0, 1, -2, and we go across. Minus, we're minusing this one. Doing the same thing, cross it out, cross out the row, cross out the column, and then we're left with 7, 0, 1, and -2, right? And we go across straight out to the end, and then we work it out, right? And we get the 48. Can somebody else tell me what the value of Y would be? Did you work it out? Reach that far?
-24.
-24. Who's saying that? Come on, man, assist me here. Who said negative 24? You want me to call on a name? Me who? I'm looking for Monisha? Nathaniel?
Natalia.
Natalia, thank you, Natalia. Very good. So everybody, anybody else has gotten negative 24?
Yes.
Yes, miss.
Somebody saying no? The person who is saying no, say, let me see, raise a hand or something. Who is saying no? Chat me. Give me a, send me a chat. Okay, so Danique, you're saying, can what she's saying be written? Which part of it, Danique? Which part of it are you? Danique, are you able to speak? No, man, never mind that. You get it now, Danique. You're good. What you said was the answer to why is negative 24. Same approach. We're replacing the middle column, which represents y. Okay, thanks, Danique. Which represents y, and we're doing the same procedure. We cross out the column and the row which we're working with. So we're left with 2, 2, 0, 4, and minus 2. We're working it out 4, and we have to multiply it by 4. So we first 1, and here you have the minus 4, and here you have the 1, and you work it out, okay? So somebody else volunteer the answer for Z.
72.
What? Repeat that?
72.
72. All right. So 72. So question. Somebody gave me 2. Somebody gave me 48. Somebody gave me negative 24. Somebody gave me 72. Is that the value of X, Y, and Z?
No, miss.
No,
Why not?
because in order to get the value of X, Y, or Z, you'd have to put the determinant over the thingy. So you'd have to put the determinant of X over the overall determinant.
Nice. Very nice. So what would be the determinant of, what would be the value of the X then?
2.
2. Is everybody with me with the 2?
Yes, miss.
Yes, miss.
Or because you're looking at the screen? You're looking at the screen. Let me see if somebody else. Shante.
Yes, miss.
Thank you very much. Kessiana, is it Henry? Are you with me with the 2? The value of X equal 2. Are you getting it?
Yes, miss.
All right. So it's all like everybody get it. So just tell me what is Z then? What is the value of Z?
Negative 1.
Z is negative 1, not Y, you know.
3.
Sorry, 3.
3, miss.
All right, nice. So what I'm asking you to do, I hear that you have a WhatsApp group. I'm going to ask you to just take down. You're all correct. So the answer, the solution is X is 2, Y is minus 1, and Z is 3. All right. What I can do is share with you the answer, the working out for this, but you need to also practice. So I'm going to ask you to work out 2 additional questions for me. And if you may, well, I'm asking you please to add me to your WhatsApp group so that you can share with me individually those answers and I'll respond accordingly. Okay, you can private message me. I'll send my number and you add me to the group, okay? These are the other two questions. Question 2. So when you see this, if you see this in the exam, evaluate and a matrix, what does this mean? With the brackets looking like this, what does it mean?
Find the determinant.
Find the determinant. No, sir. This one right. Very good. Find the determinant. And we're learning and we're teaching each other, okay? So this is the place for us to make the mistake, not in the exam. Right here, okay? And so take this down, question 2 and question 3. I'm gonna send my number in the chat so that at the end or before Friday, you can send me your responses and I'll respond in the chat privately. As you send it, I'll respond to you, okay? So this is question 3 that we were going to work out.
Miss, you can go back on the second question, please.
Sure. So everybody is comfortable with question 1? Any questions?
No question, Miss.
We say no question.
Miss Shanti.
Shante. So Kesiana, Kesana, Kamisha, all. Davia, no question. You're good. Danik, no question.
No question, Miss.
All right, good then, no man, we're good. May I move on to show you question 3?
Yes, Miss.
Sure. And we need to ask Mr. Shand a question if we can introduce the other format which is acceptable by CAPE. You might find it easier, but we're gonna ensure that we have Kramer's rule lock, right? So once we're going to start with the first element, I don't want to see anything in that row or in that column that the first element is in. And you just multiply it, put it outside of the, the bracket, and you have the 2 by 2 matrix and you multiply it out, right? And you go across the row. And as Tatiana says, the plus, the minus, the plus. So everybody get question 3. Let's welcome Mr. Shand. Take 2 minutes and welcome Mr. Shand. So everybody has question 3. I want to assist, I want to help. I want to ensure that you get the practice, okay?
Yes, Miss.
Yes, Miss.
Nice. Mr. Shand?
I'm right here, Miss. I'm right here. Give me half a second. I'm right here.
Okay, nice. And thank you, students. Thank you very much for participating. And I look forward to even provide you with more practice. Because I know sometimes we work, we don't have much time. So if you have any question at all, not to say that I know, but I can research and help guide you. So anybody wants to see the working out for question 1 that we just did, remodeling, until Mr. Shan comes?
Nice. Thank you, Mrs. Henning. Very nice. I need to ask a few questions though. Natty, unmute for me.
Yes, sir.
Where you eat for lunch today?
So what you mean?
Ask your question. Ask your question. Where you eat for your lunch today?
So I did I sleep on a lunchtime.
You did sleep at lunchtime?
Yes, sir.
Favor. You see, every other lunchtime as of today, drop asleep.
Sleep?
Yeah.
All right, sir.
Because I hear you answer question and my blood get chilled. Very nice. Very, very nice. I'm really proud of you. Not that the ones of the others of you who were answering that I'm not proud of. Yeah, but you know, I know and Natty knows, and it suggests to me that you have been doing some work, guys. There are some of you still that I hear Mrs. Henningham trying to plead for you to respond. And it's the same ones responding, Shanti and the Tatiana and the Tanil and none of them on them. I'm listening now, not one of them. Let me see if any one of them there for us tonight. Mr. Powers is here. Not even one time to say, hello, miss, my name is Mr. Powers. And the answer is that nothing. All right. So thank you, miss. Of course, you'll stay on for the rest of the session. And I'm pretty pleased with the revision. I was listening intently for the stuff. Now, the syllabus, Mrs. Henningham, didn't speak of us identifying the minor of the matrix. However, they know what the minor is. They may not know the name, but they know how to find the minor, how to reduce the 3 by 3 into the other sequence of 2 by 2 matrices. And I'm happy that they remember how to write it in the A+B form. And I'm also happy that they recognize that when you're given a matrix in the 2 strokes, like a modulus or the absolute value sign, that it means that you're calculating the determinant. So I'm happy that you remembered. And Mrs. Henningham is going to share with you the document here so that you can have those 2 questions completed. And I'm going to ask that you do just that so we can get additional help. So join me in thanking Miss for tonight. On Friday, again, she will move on into another area. So I would love if you will have those questions answered before next class so that she can respond to you. Because based on her agenda, I think she's going to be doing some additional revision in other areas. So thanks again. So are there any other questions before we move?
No, sir.
No, sir.
No, sir.
No, sir.
And me kind of have up one person. I mean, me need to clear my chest. You see, oh, Miss Alvaranga don't come to my class and talk to my class, but Miss come our class and Alvaranga talk out, blow, you know. Alvaranga talk out, and I say, but wait, and me, Alvaranga don't like. But never mind, Alvaranga. I'm proud of you. It suggests that you are indeed learning. And I thank you guys for being the students that you are. Now, remember, we don't all learn at the same pace. We are not all at the same pace or level or stage, even though the topics have been previously covered. And again, you just had a tutorial session / review. And I would love if you guys would benefit greatly from these exercises. So please, I'm going to ask that to turn out. So again, remember, I used to give you a 15 minutes break. And no, forgive me, those of you who had, is it bio 3 to 5 or chemistry 3 to 5 today? Because bio 3 to 5 don't.
Chemistry.
Chemistry.
Because chemistry 3 to 5, sorry. I know those who had chemistry 3 to 5, I took you guys into consideration. That's why I gave you a 15 minutes break before the start of the class. But since Mrs. Henningham is here with us, I am going to take back those 15 minutes so at least we can get some work done up in that in that regard, as I explained to you in the WhatsApp group earlier. Is that okay?
Yes, sir.
Yes, sir.
All right. So I want you to work with me. Thanks again, Miss. Of course, you used to be here with us, but um, I'm going to ask you to do me a favor. Um, I have to start. I have to start the calculus. I feel like I'm going backwards. I know we have been doing pretty well with the other areas. I know we did or unit 2 with the coordinate geometry. There are about 2 little areas that I need to finish off. But the truth is, I feel it in my spirit that, and I like following the spirit, the leading of the Holy Spirit, that I must begin another module with you tonight. And as a result, I'm not even going to be opening the notes on those 2 little areas. Now, the unit 1 is very short. I can use a 1 class to finish off the unit 1. Very short, just numbers, very short, 3 little things on it. And I have 2 other small things. One is the graph and another one. So I just have 3 small things to finish off, but I have to start. I feel very guilty. Not that you are not moving, because remember, we started back on the 25th of October. I'm not hearing anything from CXC. So it look like them don't have any desires to push back anything, because I think CXC really wants to go back to their regular schedule. So I need to do an introduction with you on or module 3. So let's go. Just gonna have a conversation with you, a little bit more than a conversation. So we're going to go through limits. We're going to go through some limits. Now, when you hear me speak of limits, tell me some words that come to mind. When you hear me speak of limits. Huh?
Boundary.
Boundary. Very nice. Anybody else? Boundary is one good word. Anybody else? Talk to me now. Anybody else?
Limitation.
Limitation, okay. What if I have $100 in my pocket? Can I spend more than $100?
No.
Okay. All right. So let me share something with you. So we're going to be looking at limits and continuity. Limits and continuity. And we need to look at the limits of different functions. Now, this conversation that I want to have with you is one where we are going to be using your intuition. We're going to be using our intuition. Now, in mathematics, we have some things that are called concrete, and and then we have those sort of imaginary, and those things that we have to think about. Concrete would be something that you can see. So if I say to you, a double-decker bus. Some of you in class may say, double-decker bus, sir. What is a double-decker bus? And some of you may even find a joke out of it. And somebody who has had an experience in other countries that have these double-decker buses will say, no, man, it means that it's a bus that has 2 levels. Some planes are double-decker. Some buses are double-deckers. I have never, have I? I can't recall. My wife actually asked me that question recently. If I've ever been on one of those aircrafts that have a double-decker. And I remember going into a very huge one at one point in time, but I can't recall if I've been into a double decker. So to be on the safe side, I would say that I've never been into a double decker on a double decker aircraft, but she has been. All right. So what's the point? It will be concrete because at least I can see it. I can say that I've experienced it. For somebody know who has not experienced one or have seen one, even in picture or television, may have to imagine what that looks like. So this intuitive approach is an imagination. We're going to picture some things. And this is one area that I'm going to be using to expand your investigatory skills and to deepen your reasoning abilities. All right. So let's go. So I'm looking at limits and I'm looking at the intuitive approach. The intuitive approach. Then, sir, them have more approaches? Absolutely. Now, if I say to you, evaluate the limit as x tends to 1 of x minus 1. I'm not sharing. I made some adjustments to this handout to my other group that I am teaching. And I want to give a narrative for how it is read, and I don't have to be retyping this stuff. So let me just refer to it. So I will amend your set of notes accordingly. When you go to class and students are asking, so yours didn't have this one, this narrative here. So the limit as x tends to 1 of x plus 1. So here is read the limit as x tend to 1. This x here, under here, let me bigify it. All right. So it is read as x tends to 1. This one here. This x is tending to 1. So when you see the arrow, it means that x is approaching 1. And that's why it's called the approach. So x is approaching 1. Now, if something is approaching 1, can it be equals to 1? Yes or no?
No.
No. Very good answer. It is only approaching. It cannot be equal to. No. Listen to that, because when you come back and say something to you, you say, boy, so you're confusing me. Or you say it can't be equal to. No, you're going to change the talk. Yeah, I'm doing this deliberately. So I'm saying to you, x is approaching 1. That means x cannot be equal to 1. X cannot be equal to 1. It is only approaching. So what do you mean by approach? It is getting closer and closer and closer. It is getting as close as it possibly can without touching. Sometimes in real life, and math is real life. In real life, you try to get close to some other some other special people in your life that you're not supposed to get in that close because the body cannot resist ourselves. And we get too close to the point where the Holy Spirit can't pass through. Right. So we need to always leave space for the Holy Spirit. All right. So that's what is happening here. X is tending to 1. X is approaching 1. It is getting so close to 1, but it not touching 1. That concept is going to come across again when we are doing the graphs that I have to do with you, right? I have some graphs plotted for you that I want to show you what is happening. All right. Now, give me a value, sir. When you say that x is approaching 1, what do you mean? Now, I want you to look from the left-hand side. That LHS means left-hand side. The LHS means left-hand side. The RHS means right-hand side. This is also a short that we use in mathematics, all right? Left-hand side, right-hand side. Now, I want you to work with me. I'm looking for a number. I'm looking for a number that is close to 1. And that number, I'm going to select to be 0.9. Then sir, why I couldn't use 0.5? Because I'm trying to get close to 1. It is approaching 1. I want it to be as close to 1 as possible, but it's not going to be 1. So from the left-hand side, so what do you mean by left-hand side? Okay, take your pencil or pens, and I want you to draw a number line. We all know what number lines look like. One of the prerequisites for this course is CXC mathematics. So we all know what the number line looks like. And you're going to mark 1 on the number line. Tell me what value you think is going to be to the left of 1. What value falls to the left of 1? Huh? Abraham, what value falls to the left of 1?
0.9.
Very good. And what value falls to the right of 1?
2.
Okay, excellent. No, let us say 2. Let us say 2, all right? So when we look at our 1, to the left of 1, we're going to have 0. Then to the right of 1, we're going to have 2. That's what the number line looks like. Now, you notice to the left of 1 is 0, but I want a value that is close to 1, and I'm going to call it 0.9. I'm calling that 0.9. My question to you is, is there a number on the number line that I can get closer than 0.9? Think about it.
So the number line can have like little strokes.
You can have little stroke, you can have big stroke. Yeah,
So
man.
0.99.
0.99.
Who was that? Was that Natty B again?
Yes,
No,
sir.
I want to keep. No, man, me like in any session you go, any praise session you go back to the earth. Very nice. Very, very nice. Yes, 0.99. Can I get closer?
0.99.
0.999. You know, I like it. We'll ask the question one more time though. Very nice. Can I get closer than 0.999?
Yes, sir. Add another 9.
Add another
Yeah.
9.
And
Excellent.
you continue add another 9.
Oh, you know what? Me ask the question again, so you tell me somebody just continue. All right, I get the gist. I get the gist, Tani. But all right, so let me ask you the question now, Tani. Let us move to the right-hand side. We said now to the right of 1. I'm telling you, to the right of 1, I am going to say 1.1. Is there another number that is closer to 1 than 1.1?
1.0.
1.0, but 1.0 the same thing as 1. But remember,
Oh, never mind, sir.
No, man, don't say never mind. Continue.
No, sir, I'm going to tell you something else. That's right.
No.
So tell me.
No.
I'm listening. Talk to teacher, please.
They're saying that there is not another number that can get close
Yes,
to 1.
man. Remember that.
Sir, 1.05.
1.05. Okay, Tani, hold on. So Tani is saying 1.05. Is there a number that is closer than 1.05, Tani?
1.01.
1.01 is closer. Very good. All right. So 1.01 is closer than 1.05, Tani. Okay, so 1.01. All right. Is there another number closer than 1.01?
Oh.
Hello, somebody.
1.001.
1.001. Thanks, Tyree. Very good. Let me see if Miss Tani will be cheeky again. So Tyree just said Miss Stanton, 1.001. Is there another number closer than 1.001?
One 1.00001.
All right, very good. All right, excellent. So this is why it's called the intuitive approach, because we need to be imagining some stuff. So yes, so from the left-hand side, I start with my 0.9. There's a number that is closer. So I'm inching closer. I cannot be equal to 1, you know. Cannot be equal to 1. All I'm doing is getting very close to 1. And then 0.99, but I can get closer, 0.999, and so forth and so on. On the right, I got to 1.1, but my next number is going to be 1.01, and then 1.001. But guess what? I still can get closer, 1.0001. And if I want to get closer, I go to 1.000, add another 0, and then put my 1. All right? So what it is that I'm doing is investigating what is happening to the left-hand side as well as to the right-hand side. You know, sometimes, and let us talk things. I mean, this is real life. And I mean, I'm sure that you guys will have an opinion on this matter. So the other night I was scrolling through TikTok, and you won't find anything about me on TikTok. I just go there to fast in people business. It's like fast book, and just to just have a good time laughing. And I won't even comment on people's stuff either. And then one night I was up and I saw the story about Delano Tucker, and immediately my heart just melt over. And then I said to myself, look, tomorrow as God send day, all being well, me I call guys in. I'm going to see if I can reach out to this young man. Rockstone, you see by the following day, people are get 10,000, people are do this. And I said, okay, this is not about me. If I'm going to do something for you, me not go up in no camera light to show you, me account out $1,000 bill for show you, say me and give you $10,000. No. If me ever give him $10,000, me ever call him and say, Brethren, push in your pocket. Yeah, and I say, who are you? That's not important. Don't worry about me. Me just want to bless you with something. And I have been watching, I have been following up. And then bam, I hear different little stories, and people are bash the mother, and people are talk about Alex, and people. What's the point, sir? The point is, there is a story. There is some story to the left, and there is some story to the right. And the person in the middle is going to come with the true story, right? Normally them say, there's your side, there's my side, and the truth. So guess what? You have Alex's side, you have the Tucker's side, and in the middle, you have the truth. In the middle, you have the one, which is the truth, because that's where the limit is tending. To the left of it, you have one party side that you're going to investigate and question. And then no, you can't just question one side and make a judgment, you know. You have to go to the other side and hear the officer, and then you know as the investigator, in the middle, say, here's the plan. I am the one. I am the number one that it is tending to. So me now going to decide now if the two stories them have come together. If the two stories them now come together and them now, I'm going to say a lie not tell, smart tell a lie. Watch what is happening. And I want each of you to do it. I'm going to do the first two, one on the left and one on the right, and I'm going to ask you to do the rest for me. So I'm investigating what is happening to the left of my one, which is a 0.9. Anywhere in the function, I see X, I'm going to substitute 0.9. 0.9 plus 1 is 1.9. Talk truth. Can you see that?
Yes, sir.
Yes, sir.
All right. Now I'm moving to the next one. 0.99 plus 1 is 1.99, don't it?
Yes, sir.
And then, and as Tani said, and so forth and so on. All of these are given this here when I substitute here. Let us go to the right-hand side. 1.1 plus 1 gives me 2.1, don't it?
Yes, sir.
Yes, sir.
And when I substitute the other values in here, my 1.01 plus 1 is 2.01, support and so on. Agreed?
Yes, sir.
Yes, sir.
What number is this on the left-hand side rounding off to? The number one.
2.
The number 2. What number is this on the right-hand side rounding off to?
2.
All right. So what we know? So we say that this limit is of a good behavior since the limit approaches 2 from the right and from the left. So in this your case, I can say that this limit is continuous, is a continuous function. There is continuity with it because the story that I get in from Alex link up with the story that I get from the mother. Alex claims them by 300 blocks. The mother says she not count 300 blocks. The mother say, "Smarty, in the auntie, somebody, uncle man from foreign send 300 US dollar." She says she not get 300 US dollar. So guess what? There is discontinuity between two parties. So you know what needs to happen, which is what should have happened from in the first place. That when this young man started this initiative, that a mediator should have stepped in to say, here the plan. I am going to, and a mediator from the government, and I'm not talking about in the latter part when money starts short, because people start contribute money left, right, and center, but it needed to have been centralized so that this central person can have the information talking about that. So I can't tell you say Alex is untruth, and I can't say that the mother is untruth. But all I can tell you, the story from the mother side, the story from Alex's side, not linking up, and something is being left out. When you're talking about continuity, you're talking about the intuitive approach. The left-hand side, the value that you get on the left-hand side has to be equal to the value that you get on the right-hand side. Both values must be the same for the limit to exist and for us to have a value. So from this here example, we can say that the limit of this function as x tends to 1 is going to be 2. It means, say, the limit can't pass 2. It means I have $1,000, and in as much as someone want to buy one 3-piece chicken at KFC, $1,200 and something feed. I don't know when KFC is so expensive, Jesus. Anyhow, so I cannot buy it. I have to go with a 1 piece, which is about $800. All right. So this is exactly what is happening. Are there any questions?
No, sir.
No, sir.
Are you all following? Is there somebody in the class that is not following this example that I just looked at? All right. Let us look at another example. And I deliberately am putting that example on screen. You know why? Students don't like fractional forms. And then somebody's going to say, so the teacher them say, no, Mrs. Henningham and Mr. Shan, the two of them are different. Them give the easy one as example, and then no give the one them the way them know you don't like. So you go sit down on your own. We not do it here. That's not the attitude. We are teaching you conceptually. So we are presenting the information to you. And then we are going to see how well now you can replicate that information into a notch higher than the one that you just did. So look at it like that. Watch me now. This limit is tending to which number?
2.
Number 2. All right, number 2. All right, hear my question. Hear my question. Give me a number that is close to 2 from the left.
1.99.
No. Hold up. I am sure you guys did mathematical investigations when you were doing your CXC. And you know, when you're doing your figures for argument's sake, you can't jump to the generalized form. You have to start from very small and you build up so that you can see a pattern. And from that pattern, you can make a generalized statement. Case in point,
the Jamaica man them worthless like. Who you talking to? Can't call me worthless. And then somebody may say, sir, you know worthless because from me born, me no know my father. My father just give me, my father never give me nothing yet. And then somebody's in the class, that's true, sir. So the man them worthless. But there's one person in the class who said, no, that is not true because my father has been and is still in my life. But guess what? The ones who spoke passionately, it will be their experience. So put it this way, if one of you went to color school, Merle Grove High, and if when you went to Merle Grove, there's a student who had an altercation with a student from the Queens, them coming, the two of them come down from Constant Spring Road, you know, and the girl from the Queens passed and apparently brushed the shoulder of a Merle Grove student, and she said, oh, sorry, but the Merle Grove student is a thug, and said, sorry, watch this, and big fight start. And somebody passing by and say, you see all the Merle Grove girl there? How many students at Merle Grove would have been in a fight?
One.
One. But in our Jamaican context, which word we use to pluralize one?
Them.
Them. Yes, man. So we're going to say the Merle Grove girl, them is just one student, you know, just one student. So I'm saying to you, it could be one father, but because we said the man, them, right? So when you look at this note, Neil, I'm saying to you, you can't just jump to a conclusion. You have to do your investigation systematically. Mathematics is a studying of patterns. No matter what you don't have to do sequence and series in order to see the pattern. Math is a studying of patterns. We did Pascal's triangle, you know its pattern. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, and so forth and so on. It is a study of patterns. And incidentally, I thought about you guys because when we had the 22nd of the 2nd, 2022, that was a palindrome. Remember I spoke to you about a palindrome?
Yes, sir.
Yeah, man. Anybody remember? Anybody thought about that when you saw when that date came? No.
No.
Yes, sir.
Yeah, man. So when you wrote that date down, 22 to 0, 22 to
2022.
No, whatever it is. No, man. It's whatever it is. Whichever way you read it, from the back to from the front, you'd have got the same value. It makes it a palindrome. I remember discussing that with you when we were doing the Pascal's triangle. So you see, I was hoping when that day came, I was like, yes, I really hope my students are having a field day with this day. Sir, there's nothing to have a field day with. No, you can tell people, say, oh, that's a palindrome. I learned that in Cape Man, right? But the point is, we have to take things from small, look at the pattern, and then we make a generalized statement. So coming back to you, Nortonil, what is the first suggested number from the left-hand side as x approaches 2?
1.9.
Very good. And then the next one will be?
1.99.
Very good. Excellent. So guys, so we're going to start with 1.9. We can't jump to 1.999. We're going to start with 1.9. Then we go to 1.99. Then we go to 1.999. And we increase it. We substitute our values. And then we investigate what is happening with those numbers. All right? Question. From the right-hand side. 2 from the right-hand side. What's the pattern? Give me a number that is close to 2 from the right-hand side.
2.1.
Good job. Excellent. Give me a number closer than 2.1.
2.01.
Excellent. Try one more for me. Very nice. Try one more for me.
2.001.
Excellent. So forth and so on. Very nice. Now, I am projecting this because I want you to see it to help those who are not following. All right. Now, I would have gone ahead and substituted the 1.9, the 1.99, the 1.999, support and so on. And I want you now to use your calculator. You know why? Because we have a fractional form. And there is something in computing that we use in mathematics that is called algorithm. It's just the working out. It's just how you set out the stuff. Some of you don't follow the algorithm properly. And I'm giving you 3 minutes to make the substitutions here into my function and tell me which of these you get as your result. And I'm going to ask you to do the same thing here. Substitute all these 4 sets of numbers and see what it is that you get once substituted if you agree with my answer. I'm giving you 3 minutes, starting now.
Sir, you can repeat what you say we must do, please.
Sorry, I stepped away. Go ahead.
You can repeat what you say we must do, please.
Substitute these values here for me into the function here and see if you get these output.
Sir,
Mm-hmm.
get them. Sir, I'm get them.
Very nice.
Same.
Mm-hmm. Is there anybody in the class that didn't get it?
Sir, I'm not
Sorry.
really sure what to do. I don't really understand what to do.
You don't understand what to do? All right. Mm-hmm. Now, some of you have calculators that show the natural display form. What do you mean by natural display, sir? You can have your fraction. See, look at this. What does it say?
A, B, over C.
Mm-hmm. Mm-hmm. That is a fractional button on your calculator. All right. The natural display form will bring it up as a fraction. Some of you just going to see it as a stroke. All right. Now watch me. 1.9 plus 1 divided by 1.9 minus 1 equal, and that's why I got the 3.222. And I'm using 4 decimal places. So that's all I'm doing. That's
Okay.
all I'm doing. Yeah, man. Let me do one more. 1.99 plus 1 into 1.99 minus 1. 3.0202. And that's all that I've been doing right here. Similarly, I did something that I shouldn't have. Similarly,
Calculator not giving me that.
your calculator not giving you that? All right. What rank calculator are you using?
Casio
FX what?
A2MS.
A2MS, very good. So look to the top left-hand corner, about the second or third button from the top left, you'll see the ABC button. Are you seeing that?
Yes, sir.
All right, do me a favor now. Watch me, watch what I'm doing on the screen. I'm opening my parentheses. I'm opening my parentheses, and I'm going to say, for example, 2.1, 2.1 plus 1, and I'm closing my parentheses. And then I can touch the division button. See the division button here? I can touch that. Then I'm going to open the parentheses again. And then I'm going to put 2.1 minus 1, close my parentheses, and then I'm going to press equal. And I'm going to get my 2.8181. Try one of them using that algorithm for me and tell me if you get the answer.
I get it.
Good job. All right. Now, this is the importance of Mrs. Henningham and Mr. Shand, saying to you, and Mr. Rookwood, for those of you in pure math, will say to you, it's important for you to walk with your calculators to class. Because the teacher, the lecturer, will take that effort in helping you how to use your calculator. It is never advisable for you to borrow a strange calculator to go into an exam. You're going to sit down and try to figure out how to use the calculator, or you're going to punch things into the calculator and the calculator give you wrong answer. Yeah, quote unquote wrong answer, because the calculator wasn't properly cleared, right? You see how many things on my calculator? So a calculator like this, you wouldn't want to borrow. Matter of fact, you can't use this calculator because this is a programmable calculator, all right? But I'm projecting my calculator so that you can see exactly what is happening. So it's very, very, very important that you own a calculator, and please do not go to Mr. Chindong Town and go buy no Kenko. Invest in a good calculator. All right. So you're okay now, everybody, in how to evaluate this thing here. If you don't have the natural display button where you can see the numerator and denominator, go ahead and use this algorithm where you can have that algorithm where you use your parentheses. It may just take a little while longer for you to do it, but it will always work. Are you okay?
Yes, sir.
Yes, sir.
All right, very good. Okay, so now what number is this on the left-hand side approaching to?
3.
3.
Oh,
Very
3,
good.
sorry.
What number do you think is this approaching to?
3.
Good. Excellent. I'm happy. I'm very happy. All right, Tani, you said something earlier, and one of the things I'm going to say, whenever I hear students speak out in class, I get very excited. I was speaking to a parent today when I was on campus, and I was saying to somebody that I don't like when on campus when I have a class to teach in the evenings, and I do this every day. I have a class every evening to teach, but speaking to a parent, and it so happens that the parent is a medical doctor, and the parent I was just having a conversation with the parent. He said, boy, COVID has done us a lot of devastation, but COVID has done us a lot of good. Real good, you know. One of the goods for teachers is the introduction to online teaching and learning. Sir, you think online a good something? Put it this way. There are many people in other jurisdictions that some of them only know online. In this year jurisdiction, not just Jamaica, but the Caribbean, online is pretty new to many of us. But guess what? Online is here to stay. Even when we go back to face-to-face fully, you know, online is here to stay. And guess what? It's when you guys move on to the university come next year, best believe that when you go back to school face-to-face, and I'm proclaiming that in Jesus' name, that come September, we can, you know, well, by August, not August, by the start of summer, my prayer is by the start of summer, COVID would have been history. All right? Me still wear my mask, you know, but COVID will still be history. I best believe, and I want you to think about this. And when it happens, when you can call me and say, sorry, it's true. Best believe that when you go to the university to study your disciplines come September of this year, that you're going to say to me, sir, this foundational course is online, or this year course is online, because we have gotten so many gains investing in online deliveries to just go and throw it through the window. And one of the things that I like with online is when students speak up. That's the point I'm making. So Tantan said something earlier, and I'm going to just use this as a teachable moment. Tantan jumped to 1.999. And I said, hold up, no man, let us do it in sequence, because when Tantan jumps to 1.999, the next number that she could jump to is 1.99999. But she's not going to see the full picture. Sir, it's still going to be 3. Watch the picture. You recognize that this value here was more than 3? Was 3 point, well, all of them more than 3, but this was way more than 3, 3.222. But when you really got closer to the number, it is actually inching closer to 3. When you get even closer to the number, it is inching even closer to the limit, and so forth and so on. You see, by the time you reach a 1.999999999, you're going to get 3 flat. Similar to over here, you recognize that this was so far from 3, 2.8181. But guess what? 2.9801 is even closer than the first one. But guess what? I'm even getting closer to 3 when I move on. So it is important that we do things systematically so that we can see the pattern that is being created. It is a pattern that is going to inform us of what to do, when to do, and how to do. All right? So math, and I dare say accounts, and Mrs. Hennington can bear me upon this one, I dare say accounts is also something systematic, where it is that you can look at trends to make informed decisions. Okay, so we are seeing that the electricity bill is going up, and is going up, or we may see that the telephone bill is consistent, so the budget that I'm going to put in is going to be this because it should take care of the electricity, right? If your water rate is at a particular point, but after a while you see that there's a spike in the water rate, is either have an underground leak, or one of the toilet them a leak, or somebody a teach the water. And that is red flag alone that you're going to check out your system. If your light bill is XYZ, and after a while you see start spike, somebody a bridge light. All right. So you have to start thinking, you know, like real investigators. You see, when I explain the limits to you this way, not only can forget it, shouldn't forget it. So watch my statement now. So we say that this limit is of a good behavior, since the limit approaches 3 from both the right-hand side and from the left-hand side. Then, sir, what if the limit from the right-hand side was a different number, was tending to a different number than to the limit of the left-hand side? My conclusion would be the limit does not exist.
Whoa.
Is there a question? So my conclusion have been the limit does not exist. All right. So I will, in order for, and a little later on, you'll see me talk about continuity. All right. Now, are there any questions? Are you following what I'm doing here?
Yes, sir.
Yes.
I again see if we're not truly a follow. Classwork, do that one for me, please. Do that one. I'm right here. Do that one. You're evaluating the limit as x tends to -1 of x over x minus 1.
Sir,
Yeah, man.
would it be approaching 2?
I don't know. Ask your classmate. Is she correct?
No. It would be tending to -1.
She's talking about the result.
Ah.
So let me ask you, is the limit overall approaching 2? What's the final answer?
So it approaches 0.5.
Approaching what?
They're approaching
Approaching
1,
no, what you said before.
0.5 the person.
So why are you changing the answer?
Sorry, sir.
I didn't
Send
I
the same
didn't
answer.
oh, I didn't hear you. Okay, fine. Okay. 1 more minute. So come to the rest of it, talk to me, man. All right, so do you all agree with her?
Yes, sir.
All right, now, you see what is happening?
Yes, sir, that's what I got.
Same.
Very nice. Now, let me just caution you on something as I'm led by the Spirit. You see, if you don't follow your teacher's instruction and do the question as he's teaching you, you may find yourself into problems. What do you mean, sir? If you say now, but I use them something here and you're going to jump to this one, and you just jump to this one and get 0.5, and then you jump to this one and can't bother to them something here and jump to this. You say, oh, 0.5, sir, and question finish. Hear me out. You run the risk of them giving you something that is not continuous, or something that could be continuous. But because you didn't follow the procedure, you're not seeing what is happening. And you may say, oh, the function is not continuous, when in fact it is, or vice versa.
Sir.
Go, mommy.
Sir, you know when a negative 0.9 or something like that if you use as X.
All right. Okay. What is the limit tending to?
-1.
-1. So write down -1 on your number line and tell me what number come to the left of -1. Momo, answer no. Parker.
-1, sir.
No, I'm saying what number comes to the left of -1? The negative 0 point something. What are you talking about?
Sorry, I hear me though.
Yeah.
Sorry to break up.
No, I'm hearing you. I'm hearing
Sorry, but
you.
you are break up sometime.
Oh, am I?
Sorry, probably my Wi-Fi still, but it's been
Yeah.
kicking out.
Um. All right. So I have this the other way around. This here supposed to be my right hand side, and that's supposed to be my left hand side.
Yes,
Sir,
sir.
confusing me.
Sorry, I'm get it overall, but just a mistake I did make.
No, but sir have the wrong labeling. So the calculation is correct, but sir had the wrong labeling right here. So I thank you for your question. Right now, again, Mrs. Henningham will make mistakes. Yeah, Mr. Shan will make mistakes. None of us is indispensable. And for those of you who recognize that it's supposed to be right hand side, left hand side, I thank you. You know sir stuff already. When he's doing this stuff, what sir do? Let me see if we can remember.
Copy and paste.
Copy and paste. And sometimes when sir copy and paste, sir don't go check back the something to say that. So what I did was just to copy and paste from the first two and just write down the numbers without even looking on it here. But yeah, inexcusable. So yes, so this is the right hand side, that's the left hand side. One of the things that I want you to do is just to make sure that if you're having a challenge figuring out what is on the left hand side versus what is on the right hand side, just do a quick thing of the number line and look to the left and the right of the number line. Look to the left and the right of the number
So
line.
what
So,
write RHS or LHS?
so oh, you didn't know left hand side from right hand side? Yeah, man.
So what if it like, I'm tell you what me do. Me never realized that me never put the RHS and the LHS thing. Sir, but me get the rest of this, me get the number them right. Me just do what me I do. But me never like label it or whatever you want. You know? Yeah.
And guess what? For now, I will say to you, fine. But in future, it's going to always be very important for you to label. As a scientist, when you are in the lab and you're working with your test tubes, you better make sure you label it as test tube A, because when you go put your phenolphthalein into one different test tube and get one different value, trouble.
No,
So
sir, me know
always,
I have to label that.
okay, all right then. Same procedure for the mathematics. All right, let's go. Let's go.
Sir?
All right, so again, it is of a good behavior. Since from the left-hand side, it's going to 0.5. Even this is going to 0.5 when you round off, you know. But guess what? You see the 0.5 even closer here, right? And again, if you go further down, well, you don't need to go further down because you get 0.5 flat. All right, so there is one other, and then I'm going to move into the other version of this. But there's one other that I want you to look at for me pretty quickly. What is this sign?
Infinity.
Let me ask a question. What is infinity?
Not sure, no. Never ending, not gonna stop.
Never ending. Hear my question, and let me see if how many of you are thinking. Give me the infinitely large number.
What, sir?
You can't give that, sir.
Why?
Because
it go on forever.
You can continue and go on and go on and go on.
Very nice. Very nice. So if you say to me the infinitely large number is 1,000, me can say 1,001. And then somebody said, but 1,002. Okay, one billion trillion quadrillion. Okay, 1 billion trillion quadrillion and 1. So infinity is a concept. Infinity is a concept that you have to understand. And based on the response I got just now, or the responses I got just now, is suggesting that, you know, the class or members of the class understand the concept of infinity. Infinity is just saying that it is a large number. Now, guess what? What is a large number? Give me a large number.
1 billion.
Okay. All right. 1 billion. I hear you. Anybody else want to try a large number and tell me what it is? Let me see if you're thinking.
1,599,999,901.
Trust me, what if me and you they have that amount of money in US dollars, not to be?
Sir,
euros.
I no lie. I'm done with life. I'm just gone.
They say, you know about the integrated math, don't?
I'm not bother with nothing at all, sir. I'm gone. Investing in some things and I'm gone. After the grade, I'm gone.
Peas and peas. No, oh gosh. All right. Okay. But can I tell a secret? You know that 10 can be an infinitely large number?
Yes, sir.
10.
Compared to 0, compared to 1,
Okay,
compared to
very
0.5.
good. Very good. Very good. So 10 can be an infinitely large number. 100, 1,000, etc. All right. So you get the concept. All right, let's go. I'm working through with this one with you. So I'm going to project this table of values here. So that's my X. And these numbers will be my infinitely large number. And this here will be my function. Now it says we need to evaluate the limit. We need to evaluate the limit. Evaluate the limit. Evaluate the limit as X tends to infinity of X over X minus 5. So I'm using X here and I'm selecting some infinitely large numbers. Then sir, 10 large. But sir, if you give me 10 Jamaican dollars, I take it and I slap you with it. Because that can't buy nothing. But if I give you 10 US dollars, I take it true, don't.
Yes, sir.
Depends.
And then we talk about depends, Tantan. And then no Tantan we say, no, sir, I want 10 euros. All right. So 10 is 10 relatively, it could mean a big number or a small number, however you look at it. So I'm selecting 10 as one of my infinitely large numbers. And I'm substituting that into my function, which is X over X plus 5. Anywhere in the function I see X, I'm putting 10. 10 divided by 10 minus 5. 10 minus 5 is 5. 10 divided by 5 is 2. Watch me. You see the point I was making earlier, say you can't just use one and just say, okay, I hit this. Look how far 2 is away from this number, and this number, and this number, and this number. Let us try 100. And again, I want you to see what is happening because a lot of you tend to make this mistake. So why are you not seeing both of them? All right, let us go. I'll go back to the other one. So let me clear the calculator. Exit, delete, clear all. F1 says clear all. Okay, let's go. So my function says, nope, that's not it. Delete. My function says X, and I'm using it as 100. 100 over 100 minus 5 is going to be equal to 20 over 19. Now, let me just show you something. Those of you who are using these calculators and you get it in that improper fraction, look for your calculator that says F to D, or you may see it says S as in shand to D. So fraction to decimal. So when I put my fraction to decimal and click it, I'm going to get 1.0526. And that's what I wrote here, 1.0526. All right. So this is what I got when I find it at an infinitely large number I call 100. I had to do another one because if this is 2 and then this jump to 1.05, the disparity between these two is just too great. So I have to go to something else. So look at what I'm going to do. I'm going into my function and I'm changing and call it 1,000. And I'm getting 1.0050. See it here, 1.0050251. And then I'm changing it. And I'm going to one more zero. And look at what is happening. 1.000500. Oh, I don't have a 10,000 yet. 1.005003. Because this 2, the 5 is greater, so I add 1 3 to give me 3. And then I'm not even going to go to that. I'm just going to go to a million. I'm just going to go to a million. And when I go to a million, I am going to add 2 zeros. And when I do that, I'm going to get 1.1, 2, 3, 4, 5 zeros and a 5. Right. So I get 1.0005. So you see what is happening? The higher I go, if I add, say 2 more zeros. You see what is happening? 1.00005. And if I add many more zeros, say 3 zeros each, 1, 2, 3, 1, 2, 3. You see what happens? It automatically rounds off to numero uno. Numero uno, number 1. So the point I'm making here is the limit is actually tending to 1. So therefore, the limit of the function is tending to 1. And you can see it here. Then, sir, why the first one gave us all the way up a 2? That's what happens. So you have to investigate. You can't just jump. You have to take it in stages. You have to investigate what is happening. When you would have investigated, then you come to your conclusion.
Sir.
Fair enough?
Sir.
I'm hearing you. Go ahead.
Okay, so I don't know if this is a dumb question, but why did you, okay, so can you use any number that comes up like in a set, I don't know what I try to say, in a set, like we use 10, 100, blah, 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 or why did you use 10 as your infinity and count up to 100 and whatever? Can you explain how you get the number itself, the infinity?
Okay, so for ease of demonstration, Danny, I could have used 5, then I could have used 55, then I could use 555, then I could use 5,555, I could have used 9, then I could have used 99, then 999. I'm just selecting sets of numbers in sequence because remember, you know, mathematics is a studying of patterns, right? So I'm going to use sequence of numbers so that you can see what pattern is happening. But the larger the number in the denominator is the closer it goes to 0. And the reverse is the closer it goes to another number. So I'm just finding some numbers in sequence, and I figure more or less for ease of calculation, 10 was a good number to start off with. But if I wanted, I could do the question with 5, then 55, then 555, then 5,555, and I just keep adding 5s.
That's what I thought. Thank you.
Bless up, bless up. All right. So that's what the intuitive approach is. That's what the intuitive approach is. Now, look at what we're going to be doing. I'm going to be introducing to you the calculation or the algebraic approach. Blow, sir, has so much approaches. Yeah, man. Y'all have graphical approach too. Y'all have graphical approach. And when we move to the graphical approach, we're going to talk about piecewise functions. Piecewise functions. All right. So let us look at the algebraic approach. Now I'm going to project something here for you. Interestingly, this question here, limit as x tends to 1 of x plus 1 is my first question right here that we went through. Now hear me out. Let me ask you a question, because you see, I like developing my concepts in such a way that you can understand. If I say to you, you and I went to Woolworth, and I say, no man, I don't want to go inside here. And I say, no, what? All right. I have I have no more than $500. I mean, yeah, no more than $500. If I'm picking up items, where do I, what is my limit to spend?
$500.
$500. All right. Very good. Excellent. You're correct. If I say to you on the other hand, no man, pick up the stuff, man. Pick up the stuff because I have at least, sorry, I don't even know how to do this. I said, no man, pick up the stuff, man, because I have at least $10,000. What does that mean to you?
You have at least, which means you have 10,000 or more.
Mm-hmm. And you don't think some again pick up $10,000 worth of stuff in Woolworth, don't? So therefore, I'm saying to you, pick up the stuff and pick them up with confidence because I should have enough money to pay for it down. That's what they're saying.
Yes, sir.
Yes, sir.
Yeah, man. And that's exactly what a lot of people don't know. This is what they're doing, you know, especially when they go to the supermarket, you know. Sometimes you go to the supermarket and hear the person say to the cashier, a $5,000 I have here, a 5,000, so no make it past 5,000. And the cashier is working. Say it again.
If it reach 5,000, cut it off.
Same way, so don't you see people do that something that they don't?
Yes, sir.
Yeah, man. So guess what now? So sometimes, you know, and this has nothing to do with my character. I mean, tooting my own horn, but sometimes I will see what I have in my hand and somebody ahead of me, you know, saying, okay, no man, put back this. And I say, but put it back. I say, put it on the thing. No, I can't do it. I say, it's all right. I'll pay for it for you. Put it, no man. He said, no man, go on with it. Because sometimes I look at cheese tricks and biscuit and something they might carry me with little snacks with the little children and so forth. I said, no, go on with it. He said, that concept is going to be taken in for the calculations approach. Watch me. Remember, I said to you at the start, and I don't want anybody to say that I'm a liar. Explain this X arrow 1 for me. What is it saying?
X is approaching 1.
X is approaching 1. Is X equals 1?
No, sir, it's approaching.
No,
and I'm still going to stick to that fact. X is not equals to 1. X is only approaching 1. All right? But hear me now. You see, for the calculations approach, you are going to let X to be equals to 1. What me say?
Let X equals 1.
Is X equals 1? Say no.
No, it's equal to 2.
X is not equals to 1. You are just going to let X equals to 1 for ease of calculation. But in your headspace, you know that X is not equals to 1. But for ease of calculation, you are going to allow X to be equals to 1. You recognize the question that Danny asked me earlier? Sir, me want to know why. I understand, you know, sir, but me want to know why you select them number here, the 10 and the 100 and the support. It's ease of calculation for me, you know. Because as I said to her, I can go to 5, 55, 555 support and so on. 9, 99, 999, I could do that. But guess what? For ease of calculation, I just use 10, 100, 1,000, 10,000. All right? So watch me now. The limit as X tends to 1 of X plus 1. Remember, X is not equal to 1. X is only approaching 1. But for ease of calculation, I am going to let X be equals to 1. So anywhere in the function I see X, I'm going to put 1. Work with me. What is 1 plus 1?
2.
All right. Look at our first question. There's so much calculation we have to go. First, say 2 is the limit right here. So with the calculations approach, we get our answer. Bam. Let us look at the second question. The limit as X tends to 2 of X plus 1 over X minus 1. Remember, for the calculations approach, X is still approaching 2, but you are going to let X be equals to 2. So anywhere in the given function you see X, you're going to put 2. What is 2 plus 1?
3.
And what is 2 minus 1?
2. 1, 1, 1.
And what is 3 divided by 1?
3.
See here? The limit approach is 3. The limit approach is 3. Oh, then sir, if we're going to the exam and them say, use the intuitive approach, we can just go substitute the values in there. Sure. And you get 0 mark because you would not have followed their instructions. You would not have followed their instructions. So you have to know the intuitive approach. You also have to know the calculations method. Now, granted, most of the questions that are asked relates to the calculations approach, but you must have a basis of understanding the intuitive approach. Why, sir? Because when I move to piecewise functions, the intuitive approach is going to be applied for the piecewise function. So if you understand the intuitive approach, when I would have gotten to piecewise functions, you're not going to have any problem because you understand this concept already. All right. So remember, you know, what I'm doing, I'm actually building on the information as we move from minute to minute and from class to class. I'm building on the information. Just remember that, right? So in building, I will recognize, what is the third question? Did I give you a third question? Okay, I changed that question. So you'll recognize now the limit as x tends to 5. X is not equal to 5, but we are going to let x equals 5. Anywhere in the function I see x, I'm going to put 5. What is 5 plus 1? 6. And 5 squares is 25. So this limit tends to 6 over 25. All right? Look at those 2 examples for me and tell me if you agree with those 2 answers that I have there.
Yes, sir.
Yes, sir.
Yes, sir.
Nice.
Yes, sir.
All right. So do you understand now the main difference between the intuitive approach and the calculations approach?
Yes, sir.
Right. And do you see that they both approaches give the same answer, give the same result?
Yes.
Now, hear me out. If I give you a question, the limit as x tends to -4 of x squared over x minus 4. I'm going to tell you which approach to use. In Jesus' name, do not use the intuitive approach. All right? If they don't say to you, use the intuitive approach, in Jesus' name, do not use the intuitive approach. As you can see, the intuitive approach is longer than the calculations approach. And I'm moving into something finally for tonight that you will see why I'm suggesting that we're going to be using at all times, unless otherwise instructed, we are going to be using the calculations approach. But I couldn't come and start with the calculations approach to tell you, say, put the 2 in other something, because you're going to be left with an idea that x is equal to 2, or whatever the limit tends to. And that would not be a true representation of that. And I would be a bad teacher to say that to you. All right. So I had to take a bit of time to talk to you about the intuitive approach. So it is that you can see that what we're doing is investigating from the left-hand side to the right-hand side. As a matter of fact, when we would move to piecewise functions, you would also recognize that that concept of looking to the left and looking to the right will be employed in you evaluating the limit of a piecewise function. And especially if they give you unknowns in the piecewise to determine, you got to do a lot of intuition there. All right, let's go. All right, brush yourself off now, because this is big school mathematics now, you know. You see why I am saying to you, I don't want you to use the intuitive approach, because the man then gives something like x squared minus 5x plus 6 over x minus 3. Who you think are going to do the intuitive approach with that? Well, not me. Definitely not me. All right. So I just want you to hear me out. If I see anything like this on your exam paper where you're going to do the intuitive approach for a question like this, I'm going to give you 0. Because you're bound to make mistakes. Besides, the amount of space that you will need to write the question, CXC is not providing that much space on the exam paper in any event. Because a question like this will carry about maybe 6 or 5 lines. All right? So do me a favor. So you're going to let x be equals to 3. You're going to let x be equals to 3. Go ahead for me and substitute 3 into the function, which is x squared minus 5x plus 6 over x minus 3, and tell me what answer you get. Start now. Substitute 3 into the function and tell me what answer, what results you got.
Sir, are the one down at the bottom where the one down at the bottom?
Yes, please.
So is it -3?
If this is -3,
No.
what you're asking me? If the answer is -3?
Yes, but let me look back over it because we're not
Sir,
sure.
I got
Zero.
0.
0.
Never mind.
Can you tell me exactly what you got, Tanya and others?
0 divided
0.
0.
0 divided by 0 is 0.
That's it.
Thank you. You got 0 divided by 0.
0.
It's not just 0, you know, but 0 divided by 0. Now, you see, when you see that form, 0 divided by 0, it is known as the indeterminate form. It is known as the indeterminate form. Indeterminate. What do I mean by indeterminate?
I don't know, sir.
Think about it. Think about it. If I ask you, if I say to you indeterminate, what do you think the word means?
Something
The
about
limit
equal to
is
0.
not determined.
Cannot determine.
You can't determine something. Very good. Can't be solved, yeah, you can't find something. There's something that you can't find. Yeah, very good. Remember, you know, mathematics is a language. And we need to speak that
Sir,
language.
we said the calculator figure.
We are talking about.
Sir, for what would it for substitute now the function? 3.
Yes, please.
Sir, and that me get error. I can't divide by 0.
You are using a Texas calculator?
No, sir.
Try it again, please.
Okay.
For me. So this form, students, when you say 0 over 0, it's a very important form. When you see infinity over infinity, it is equally important. So for what it is that you are studying, you are going to be looking at 0 over 0 and infinity over infinity. Whichever of the two forms you get, 0 over 0 or infinity over infinity, we are going to say that it is indeterminate.
Sir,
So
me get error.
Can't get error, man.
Maybe we can't divide.
Try working the first equation first, then write the second one, and then you get it. So plug in 3 in the first, the one at the top, and then put on the answer, and then plug in 3 at the bottom one, and you get the answer.
Watch me, Matty. 3 squares minus 5 times 3 plus 6 over 3 minus 3. You see that it says math error? You know why it says math error? Tell me why.
X.
Tell me why no?
Because I can't divide by 0.
Very good. Very good. But when you do the calculation, when you do the calculation, 3 squares, and that's what Penny was saying to you earlier, do them separately. 3 squares. Okay, yes, I hear you. I know. What Tanya you saying? Do them separately. 3 squares equals 9. Minus 5 times 3 is 15. 9 minus 15 is minus 6. Minus 6 plus 6 is 0. So the numerator works out to be 0. And 3 minus 3 is 0. So you're going to end up with 0 over 0, which is why I'm saying to you, don't say 0. Because if you give me 0 as the answer, you are incorrect. Sir, why? Isn't 0 over 0 0? But remember, you're not allowed to divide by 0. Talk truth.
Yes, sir.
Yeah, man, you're not allowed to divide by 0. So I can't say the answer is 0, sir. No. You are not allowed to divide by 0. So you have to say to me 0 over 0. And that now tells me that I'm talking about something that is indeterminate. It tells me now that I'm speaking about something that is indeterminate. I'm going to make a notation of that so you can see what is happening. All right, watch me now. Watch me. So you see, because it is indeterminate, hear my story. There is something inside of the function that is preventing the true limit from coming out. You know, sometimes I have friends in a school will make you waste time, and the teacher say, boys, it's a pity, you don't understand the potential you have. Yeah, man. The teacher will say, you don't understand the potential you have, but you're waste time with them, the boy there, or you're waste time with them, the girl there, or whatever the situation is, Because the teacher is seeing that when you sit down and learn a lesson, it is well learned. So that's what it is. There's something inside of the function. Now, let me just tell you something. You see a while ago when I put 0, when I put the numerator to be 0 and then I put in the denominator, it says math error. It says math error. Why? Because
You can't divide 0 by 0.
a 0 cannot exist in the denominator. So whereas I can have a 0 existing in the numerator, I cannot have a 0 existing in the denominator. When I put in 3, I'm going to have 3 minus 3. So it means that this x minus 3 is that friend that the teacher is warning you against. Be careful, because that student smokes, follows the wrong crowd, and old time people say, show me your friends and I tell you who you are. You may be walking with a friend and something bad happens to you because you're in the company of that friend. Old time people also say, quack out, can't catch quack out, catch him short. So the teacher always warns and the parents always warn, right? For you not to do some things so that you are protected. I am saying to you, there is something inside a function that is preventing the true limit from coming out. What is inside the function is going to be x minus 3, because you can't have x minus 3 existing in the denominator. You can't have a 0 in the denominator. So the x minus 3 cannot exist because 3 minus 3 is 0. So what is going to happen is there's something here. This x minus 3 must be contained in this numerator. That's what I'm thinking. Since I know I can't have a 0 existing in the denominator, I am thinking that an x minus 3 is in the numerator where I can cancel it out. Let us check. Watch this story. So I am getting my indeterminate form. See, I do it right here, so I'll show you. I didn't even recognize that I had done it for you. I did it right here, and I'm getting my indeterminate form. So look at my little story. If the function is of an indeterminate form, we need to perform one of the following methods: rationalization, factorization, or simplification. Sir, why? Something is inside of the function preventing the true limit of the function to come out. So in order for us to get the true limit to come out, we have to perform an operation. What is that operation? either a rationalization, a factorization, or a simplification. Now in this case, because I recognize this to be a trinomial x squared minus 5x plus 6, I'm going to be factorizing. And remember, sir just finished this business of factorization with you. Sir just finished this business of factorization with you. So you see what I'm saying to you again? I am building on the information. I am building. Let's continue to build. X squared minus 5x plus 6. Remember, I am multiplying the coefficient of x squared by the constant. 1 times 6 is 6. I need two numbers. When multiplied together will give me 6, but when added will give me -5. And I will see that my factors are -3 and -2. So how you get it? When I prime factorize, I'm going to end up with 3 and 2. And -3 times -2 is +6. Yes, that's what I want. Why, sir? This one, the coefficient of x squared is 1, multiplied by the constant, which is a +6. So +1 times a +6 gives me a +6. And when I multiply -3 by -2, I get a +6. Okay, so that satisfies that condition. The other condition now is that when the numbers are added, it gives me the middle number. But when I add -3 to -2, I get -5. So again, the second of the two conditions are met. So since the second of the two conditions are met, I can safely say that I found my factors. Now I'm going to break up my middle number, my -5x, sorry, into -3x and -2x. I'm in a group, put them two in one bracket, see it right here, so. Remember the middle sign is left out every single time. The middle sign is left out every single time. Then I'm going to have my 2x minus 6 in the other bracket. Question. What is common here? That is common here. Your answer is?
X.
And I take it out. Very good. When I take an x from here, I'm going to have an x left. When I take an x from here, I'm going to have -3 left. What is common here that is common there is 2.
2.
Oh, before, remember when this is a minus sign, you have to flip a sign down. Remember when this is a negative sign here, if this is negative, it's going to become positive, and it's positive, it's going to become negative. Remember always that the sign that is here must be the same sign that is here. So what is common here to common here is going to be 2. What is left? I take off the 2, I'm going to have x. And I factor 2 from 6, I'm going to have 3. And because I follow the rules with this negative sign being here, and I flip the sign above it to get this negative, it means now that I have an x minus 3 common here and an x minus 3 common here. When I factor over my x minus 3, I'm going to have x minus 2 that's left. So remember, this is a question that they gave me. This was the original question. So because I know that there is something inside of the limit preventing the truest form of the limit to come out, I have to do one of 3 things: a simplification, a rationalization, or a factorization. Having now factorized a function, I recognize that there is an x minus 3, as I suspected, in the numerator. So you know what I'm going to do? Cancel him out. Cancel him out. When I cancel him out, bam, bam, goes. So all I'm left with now, I've reduced the function to just x minus 2. But sir, you know, change the function? Nope, I haven't. Yeah.
Sir, I'm not telling no lies. After you do the little 0 over the 0 thing, sir, you lost me. You dropped me off run at one part and go away.
All the way up here, so?
Sir, you dropped me off run at one part and you go away.
No, but not to be. Remember, no, you know, What we did in class on today's which day, Monday, on Friday, was questions involving this factorization, you know. So you have to go review the factorization.
So I
Because
think
remember,
that's going to be one issue. So someone to before that part there.
there's nothing before the part after we get the 0 by 0. The
So
part
after
here,
you get this,
after we get the 0, 0, yeah, man. After we get the 0 by 0, you know, and recognize that I have the indeterminate form, then I'm going to recognize that I have to do one of three things: factorization, simplification, or rationalization. And of the three things, I recognize that the function can factorize because they're trinomial. So all I'm doing here, after the 0 by 0, the indeterminate form, I know I have to go do one of these three methods. So all I'm doing now is a factorization. So once I factorize, watch me. What is in the numerator, whatever I'm factorizing, I'm going to substitute it for my factored form. My factored form is going to be x minus 2 times x minus 3. And all I do from there, see the original question here, so no. All I'm doing from there is substituting this factored form for the numerator. So this piece, let me show you. This piece, x minus 2 times x minus 3, is replacing this for this. So in my factored form, I'm getting x minus 2 times x minus 3. See there? And then my next step is to replace it with this. So why are you replacing it with that? Because this x squared minus 5x plus 6 is what I factorize, x squared minus 5x plus 6. So it's one of the same. It's like you having ice and then you have water. It's the same, but in different forms. One is solid, one is liquid. You can have cooked rice, but if you spoil it, you're going to have rice porridge. Can it be eaten? Yes, but it tastes nasty. Right? So some people eat rice porridge, some people eat rice. All right? So it's just one form different from the other form. You know, and I can't go through so many more other examples. All right? And then no, the only thing that I'm going to do thereafter is to cancel out what I suspected would have been what was preventing the true limit from coming out. And then now I'm going to be having my x minus 2 that is left. So I have now reduced this original question, reduce it into this piece here. Now I'm going to substitute my 3 into the function. Wherever in the function, remember we're using the calculations method, you know. Wherever in the function I see x, I am putting 3. So why 3? Because the limit is tending to 3. Oh, so if it was 1, I'd put in 1. Yes. Right? So when I say 3 minus 2, I'm going to get 1. And that's why the answer for this question here is 1. Any other question?
No, sir.
Are you seeing what is happening here, class? Or are you sleeping?
Processing.
All right. We have 5 minutes. Do you want us to try this one in 5 minutes? We can start it. Let me help you up with the first piece. So when we get the question says the limit as x tends to 4 of x plus 1 over x squared minus 1. What we're going to do is substitute into the function. This is interesting. We're going to substitute into the function. What is x plus 1? What is 4 plus 1?
5.
5.
And what is 4 squares?
16.
16.
What is 16 minus 1?
15.
Oh,
What is 5 divided by 15?
A third.
0.3.
All right. So you see what I'm saying? 1/3. No, we don't normally use a fractional form. The decimal form, sorry.
Okay, so a third.
Right. So we use a fractional form. Now, you see, since we didn't get 0 over 0, we never get, you recognize we never get 0 over 0?
Yes, sir.
Yes, sir.
So it suggests that the question is not of an indeterminate form. So we don't have no need to go and factorize, simplify, or rationalize. Oh, it's only when you get the 0 over 0, sir, you have to factorize, simplify, or rationalize. Yeah. Yeah.
Sir, but how are you supposed to know that? You're going to calculate, and if it's not 0 over 0, then you have to go find an next way to do it. Sir, we don't have that much time. So we're not going to have that much time in the exam to.
Absolutely. What is x squared? What is x squared minus 1 known as? Okay, that is a problem. Because at this level, we should all know that x squared minus 1 is the difference of 2 squares. And in factorizing x squared minus 1, you're going to have x plus 1 times x minus 1. See it here, so? X plus 1 times x minus 1. And then you'll recognize that the x plus 1s cancel out. The x plus 1s can cancel out, so it's going to have 1 over x minus 1. And 1, see the 1 here. And if this is 4, 4 minus 1 is going to be 3. So whichever way I do it, even if I factorize here, so, and cancel out here, so, I still end up with 1/3. The point I'm making is, once you substitute the value here, and you don't get 0 over 0, you do not have an indeterminate form. And once you don't have an indeterminate form, you'll get the limit of the function. If, on the other hand, you substitute and get 0 over 0, go no further for now. Write down your statement. Indeterminate form, 0 over 0. Then you have to look at the function now. Should I rationalize? Should I simplify? Should I factorize? So how are we going to know which one to do? Just like when you see a chicken in the fridge. Should I curry you, brown stew you, fry you, fricassee you, boil you, jerk you, whatever it is? It's the same way you're going to be looking at the question and asking, what is it that am I supposed to be doing? Is it a simplification? Is it a factorization? Or is it a rationalization? All right? 3 simple operations that we're going to be asked to do. All right? I'm going to stop here. I wrote this just to bring across the point that when we substituted the value here, we did not get 0 over 0. We got an answer. We got a different answer to be 1 over 3, and it's not 0 over 0. So my limit is going to be 1/3. My limit is going to be 1/3. My limit is going to be 1/3. Oh Lord, I hate when that happens. The point I'm making is, if you note, I would still, if I went ahead and factorized, I'd have been able to cancel my x plus 1, my x plus 1 here, my x plus 1 here, and I'll be left now with 1 over x minus 1. And if x is 4, this one is this one, 4 minus 1 is going to be 3. So I still end up with my 1/3, as if, I would have done it here. So whichever way I do it, I still will have factorized. However, going ahead and factorizing the question, when you already get the 1/3, is working the question 2 times. And you don't need to work the question twice. That's it. Are there any questions?
No, sir, not right now.
No,
No,
sir.
sir.
Right. Was I clear as mud?
Yes, sir.
Yes,
Yes.
sir.
All right. So I'm going to ask you. You have work for Mrs. Henning Ham to do. I'm going to ask you to add her to the group so that she can see what is happening. You can post the grade, the work, and she can see what is happening. Remember, I had to take a break, guys, to start this module 2 because I feel like I'm not moving, and our accelerated program, I have to go through. I mean, we have 2 more months after when this month is finished. We just have May, April. No, it's 2 months. This is March. And after April, then the exam is the 2nd of May. So I have literally like 6 weeks to finish the syllabus. Literally 6 weeks to finish the syllabus, right? So I'm gonna ask that when I start running, you guys understand with me. I mean, I have gone ahead and prepared the calculus notes for you. I will ask you to just run ahead with me. You have to complete your Editsoft. In the process, the Editsoft also assists. And some of you broken on your ears because some of you don't even do one piece of Editsoft. But you know, at the end of the class, I'm going to end the class on a good note. Thank you for coming out. Remember to say a gentle Jesus before you retire. Yes, please. Go ahead.
So I can check the chat, please.
Oh, yeah, we'll do. All right, no problem. Send me something privately after class. Well, not immediately after, at about 10 o'clock. All right?
Okay, sir.
Have a good one, guys. Thank you.
Bye, sir.
Bye, sir.
All right,
Bye,
okay.
sir.
Bye, sir.
Mhm.